Think about A.
No.
Why?
Well, because they're not parallel.
Okay.
They're not parallel.
Yes, because all they gave us was what? What are these angles called?
It's not like one of the things.
It's not one of the special angles. You're right. It's not. All they gave me were these vertical angles, and that doesn't help me. They're not corresponding. They're not consecutive. They're not alternate interior, alternate exterior. There's not enough information. There's nothing on this line to say anything about anything, so I cannot say that they are parallel. Oh, look at this one. I think I just covered that one in the homework. Ladies and gentlemen, is there enough information to say that these lines are parallel, these two lines right here? Yeah. Is there enough information? Yeah. Yes, there is. How would I do that? Hayden?
Add them.
Add what?
Add a boy.
So you add the 2 degrees. They add up to 180.
Okay. So right now we're looking at these two. I don't want to add these two. I want to add.
Well, they do.
Well, they are the same number, but to show, yes, this is you add these. Consecutive interior have to add up to 180, and they do. So write this down, you guys. Consecutive interior converse. Because of the consecutive interior converse. Tristan, if you get out of your seat one more, you're leaving my room. Just saying. Stay in your seat for 10 minutes. Okay. Then yes, they are parallel. All right. Euclid's parallel postulate. Now, you guys have this on your sheet already. It's called postulate 10. Look at your sheet. Do you have postulate 10 on there? You should. You might not have labeled it postulate 10, but if you didn't label it, you might want to. It says, given a line and any point not on the line, there is exactly one line through the point and parallel to the given line. All right, let's draw a picture. This is given. And this point is given. So they gave me those two things, a line and a point. And all this is saying is that there is only one line through this point that would be parallel to the given line. That's all it's saying. Okay? All right, perpendicular line postulate. This is just like the construction that you did. This is postulate 11 on your list. Postulate 11 on your list. It says, given a line and any point not on the line. So I might have a line here that was given to me. And any point not on the line, this is given to me. There's exactly one line through the point and perpendicular to the given line, which you guys just demonstrated in your construction. There's only one line that will be perpendicular. It goes through that point and hits that line. That's all that's saying, postulate 11. Okay, turn the page. All right, lines perpendicular to a transversal theorem. So we were looking at all these ways we could tell lines are parallel by these special angles. Here's one more way to tell. It says the lines perpendicular to a transversal theorem. This is theorem 3.12 on your sheet. You should have it typed on your sheet already. In a plane, if two lines are perpendicular, these two lines are perpendicular to the same line, then they are parallel to each other. That's exactly what it's saying. So right here it says, if M is perpendicular to P, and N is perpendicular to P, then M is parallel to P. This means parallel. So they're saying if M is perpendicular to P and N is perpendicular to P, then we can say that M and N are parallel. Okay? All right, transitive property. Hey, we saw this word before in 1 or 2. I can't even remember what chapter it was, but we saw it before with angles. This is how we saw it. This has nothing to do with what we're talking about here except for using the word transitive. If I say angle A is congruent to angle B, and angle B is congruent to angle C, I can say what about A and C? Yeah, they can say they're congruent because they're both congruent to the same angle. So using the transitive property, I could say that angle A was congruent to angle C. That was in chapter 1, I believe. Well, it's the same thing with parallel lines. Exactly the same thing. Okay, if I say if 2 lines are parallel to a 3rd line, then they are parallel to each other. So for example, I'll wait till you write that. If 2 lines are parallel to a 3rd line, then they are parallel to each other. So if I can say that A is parallel to B, write that down. A is parallel to B, and B is parallel to C. Yeah, then I can say, look, A and C are both parallel to B, so then I can say that A is parallel to C. Isn't that nifty?
Very nifty.
That's pretty neat.
That's right, that's pretty neat. Isn't that neat? All right. That's right. Each horizontal piece of window blinds shown is called a slat. Each slat is parallel to the slat immediately below it. Explain why the top slat is parallel to the bottom slat. So, they're saying that this is parallel to this is parallel to this, all the way down. Okay? All the way down. So, hey, gentlemen, up here. How can I say then that this top slat is parallel to that slat? What can I use to say that? Who said it? Morgan said it. The what?
Morgan.
The transitive property. Okay? Look, since all the slats between are parallel to each other, Slat. Do you like that word?
No, I like
It's a gross word, like moist.
Then the transitive. Enough. Yes. Okay. Each line in between is parallel. Then the first and the last have to be parallel. Oh, isn't that tough?
Come on,
Jeez. That's geometry more than algebra. Okay. X. That makes the 2 given lines parallel. Hey, eyes up here. Shh. If these lines are parallel, and this one is 90 degrees, what does this have to be?
90 degrees.
Okay, so 90 degrees. So that means that 2x plus 2
Equals 90.
has to equal 90.
48.
That's a 9.
So subtract 2 equals 88. X equals 44. That means X has to be 44 to make this 90. And if they're both 90, then this line and this line are parallel.
That is awesome.
Okay? All right. All right, you do this one then. You do this one.
All by myself?
Right now. All by You should get X equals 16. Now, before I let you go to start your homework, because you got 15 minutes and you could probably get it done, I want you to look at page 146, right here. Ladies and gentlemen, when you are working on your homework and you start looking at it and saying, oh my gosh, I don't know what to do. Hey,
Oh my God.
you look at this table and you say, okay, the corresponding angles converse. That's on page 137 if I need to refer to that. This table is really, really helpful when you're starting your homework. It's also on the chart that you typed up. So you might need to use that, okay? You might want to draw pictures on your chart. Tristan, stay with me. I'm almost done. You might want to draw pictures. It's on page 146. Page 146, okay? So you should get out a piece of paper. You could start this homework so you can write some more, right, Sam?
Yeah.
Mm-hmm.
Yeah.